Welcome, everyone. Welcome to the WITS workshops. I will be your MC for today's workshop on behalf of the WITS workshop committee. My name is Lina Mariette. I am a scientist with a PhD in physics. I am also an entrepreneur and consultant, and I love to provide guidance to women who want to make a career transition to the amazing world of data science and AI. Let me tell you that today's workshop is very unique. We're going to learn about a topic that we don't see very often. The workshop title is Misogyny Detection using Sentiment Analysis and will be presented by Valeria Vera Lagos. Valeria is a software developer specializing in data. She's passionate about developing solutions for social problems and technology. Her journey has been shaped by diverse experiences, from researching in natural language processing to developing hardware validation solutions. She's eager to strengthen her technical proficiency in machine learning, especially in deep models like large language models. Valeria will answer questions during her workshop and also at the end, so please add them to the Q&A as we go. Please welcome Valeria.
Hey everyone, thank you Lina for that amazing introduction, and thank you everyone for being here. I'm really excited to see people from all around the world. I'm really excited to be talking about this amazing work related to AI, but also an important topic related to misogyny. So you all by this point have access to the notebook that we previously shared. And I'll be going through the same notebook, but from an HTML format, but we will be looking at the same code. So I will suggest for everyone to make a copy of the notebook so you can make changes, run the code, look at the variables while we're going through the workshop. I'll be looking at the same content. I'll be just not running the code itself. Also, as Lina just mentioned, the main idea of this workshop is to become a conversation. So please feel free to ask any questions. I will be going through different sections of the workshop, and I will stop to see if anyone is in the middle of the code, if you have a problem, if you want to understand something more deeply. And also I will share my LinkedIn profile and my email at the end, if in case you want to keep talking about this project or share any type of knowledge that comes during the workshop. I will not be looking at the chat, but I will be looking at the Q&A box. So let's jump into the workshop, and let's start talking a little bit about the agenda for today. So we will be looking at a little bit of the definition for misogyny. We'll jump into the technical part, which is the data collection and cleaning. We'll talk about some models really quickly about machine learning and deep learning techniques, and we'll dive deep into large language models and how to use them for these problems. And finally, small results and conclusions for wrapping up. Perfect. So we will start talking about misogyny. It's a problem that we are aware of, and it's the hate or loathing towards women, and it's manifested like as denigration, violence, or discriminations against them. And sexism and misogyny can be very obvious in our society nowadays. Unfortunately, we can think about women experiencing economic disadvantages in the workforce, in healthcare, unfortunately, some type of violence in public places, and street harassment. So those are very obvious ways of looking at misogyny. But there are sexism that exist in society that are more subtle and that are not always very tangible, and we cannot see what's the impact of that in women. I just want to advise that the topic that we're gonna go through, it's a sensitive topic. And even though the main objective of the workshop is to be technical and to learn about data science, and we will not be looking at the data itself, we will not be looking at examples of misogynistic text, just because it's not the objective of the workshop, but you will have access to the data set that contains a lot of text data related to misogyny. So please be careful when you look at the data and when you use it. I just wanted to advise, there's a lot of data out there. Jumping into the first problem that we're going to be looking at, it's misogyny in social media. And today, people spend twice as much time socializing online versus in person. We all use all these platforms, and the growth of them has also increased the violence against women through the replication of hate speech that happens in our daily lives. Women are verbally abused on Twitter every 30 seconds, and this is data from 2017. These might have increased. And some of the structures that happen in real life, for example, BIPOC women are about 3 times as likely to be mentioned by problematic or abusive tweets than white women. So these structures are being replicated on social media as well. For example, Black women are 8 times as likely to be targeted by these tweets. So it's a huge problem that social media is not being able to handle correctly. And even though they have done a great effort into providing more secure platforms for everyone, it is very difficult to distinguish something that is very aggressive or sexist to something that is more subtle. So if you think about something, about a text that doesn't look like it's aggressive, but it can have a huge impact if it's sexist. Another huge problem that this has is that most of the analyses around misogyny and violence towards women are done in English, leaving the other languages without notice. And even within the English texts, they do not check the place of origins of these texts. So misogyny has a lot of culture into it. So imagine you say something in the US that might be misogynistic, even in another country with the same language, in the UK, it might not be misogynistic. It really depends on the context of where it happens. So it's a really complex problem that has to be deeply analyzed, and we haven't taken the time to research about it. And also related to violence towards women, but in a different scenario, is the misogyny in communication platforms. So there is an analysis about revictimization performed in Argentina that revealed that 70% of reports of violence against women that were published by more than 20 media platforms revictimize the victims. And this provides a dangerous framework that justifies violence acts and promotes the misogynistic culture that we already have, or it can even jeopardize judicial investigations. So communication platforms should be to objectively inform the public without giving any of their opinions, but they haven't been able to do so. For example, Mexican media has also been part of revictimization in cases where they gave their personal opinions and femicides that unfortunately became very popular because of that. And these led to a lot of comments from the media to support violence against women and stigmatize, create that women are guilty, untrustworthy, or even sexualized, which creates a sense of revictimization for the survivors or for the witnesses' families. And this is another type of violence against women, which is media violence. So when we're thinking about misogyny, we see these two different types of misogyny. We have misogyny in social media that can either be very clear or very subtle, but impacts women in their daily lives. And then we have this type of media violence where it can be, when you think about a more serious type of content, you might think these communication platforms should be very objective. There shouldn't be misogyny here, but there is, and we need to analyze it. And there are still problems in these type of medias that we need to look at. Therefore, the objective of this work and this research is to train multiple models to classify if a text is either misogynistic or not. And the main idea of this research is that technology nowadays has been performing really well, especially with text. And over the last few years, it has increased all of this technology. It has become more and more accurate. So if we have this amazing technology, how can we use it to look at these type of problems that are very complex? How can we obtain the patterns behind these misogynistic text for us to analyze it and maybe find some solutions to it? In that way, this research has been performed in the past, and it has been evaluated in terms of accuracy, precision, and a deep understanding of how the classifier works. But for us to do that, we will need to look at the at the data itself, which is something that, again, we don't want to do during this workshop. So for the workshop, we will be focusing on the accuracy of the models. But I just want to state that when we're working with this type of data, it's very, very important to look at the results of our models and see how the data is being transformed and what type of results we're obtaining. Okay, so we will start with the technical part of the workshop, and we start with our data collection. First, for us to obtain the articles, or all the articles were obtained in 2020, and all the tweets were obtained in 2019. The articles were obtained using Web Scrapper and the Beautiful Soup package from Python by manually looking for the URLs in order to bring all of them back. And the tweets, I didn't add the code for bringing the tweets because the API is no longer supported. This was back when Twitter was called Twitter and the API was free and open. So, but I'm happy to share how the data was collected and being very transparent about it if anyone is interested in that. This is just an example of the code on how to obtain it. The data sets are already collected and cleaned, so we will be obtaining that from the repo that we have just right here. So you can actually connect to the repo, download, and we have two data sets. We have them completely separated. One are the data sets for the tweets, and the other is the data sets for the articles. If we want to give a quick glance of how they look like, the tweets are around 10,000 tweets, and we made a huge effort of having a balanced class, 5,000 non-misogynistic, which are assigned to label 0, and 5,000 misogynistic tweets that are assigned to label 1. There was a great effort to create this data set. On the other hand, for articles, we have around 10K articles collected, but unfortunately, it has been very hard to manually label these. Therefore, we only have around 200 labeled articles. And I just want to state here that having such a small number of articles does impact our models, and we will see these when we're talking about the models and results. But we also need to think that manually labeling these type of articles and tweets impacts the mental health of the person doing so. And also there need to be ethical ways of approaching these and for us to obtain really clean and high quality data sets. So it's something that we will be talking about during the workshop. Once that we have our data sets, we will move into the data cleaning portion of it. So we will use a package, a really known package, which is NLTK, has been used over the last years. And something that I want to state here is that it's very important when you're using other languages and tools for other languages. Sometimes we have seen that these packages are very good at English, but they are not very good at some other languages. So for example, I was looking at the languages that NLTK has for stop words, and they have Spanish, but they don't specify the Spanish from which region or which country. So I was looking at the words, and I suggest that everyone should look at the words before just cleaning or removing whatever from your text. And I noticed that most of the words are flexed or are words that are very common in Spanish from Spain compared to Spanish from other regions, especially from Latin America. So there were some false words that I wanted to remove. For example, another type of stop words that are normally removed within text are pronouns, which are not very useful in some other classification tests. But for us, in Spanish, pronouns contain gender. And since we're talking about misogyny, we do want to keep the gender because it might be useful for a classifier to know this data. So we want to keep those. And for example, another true stop words that I started to look at while working with these would be days of the week, months, names. So there were others that were added. So I would always recommend to look at your stop words and think about the problem that you have in hand. Then we will be performing a really simple cleaning text using regex and removing the stop words that we just mentioned. before jumping into machine learning, I think there is no question right now in the Q&A, so I'll continue into our classifiers. And we'll first start with a really baseline model. I will not go deeply into it. I think there's a lot of content regarding these type of classifiers, so we have a little bit more time for the large language models. So again, we're performing a binary type of classification, either misogynistic or not, a label 0 or a label 1. And we're going to use SVM, which is an effective algorithm when the data is linearly separable. And we're just going to use it as a baseline because it's easy to implement, it's cheap, and we just want to use it at the beginning. We will be performing a super quick, small pipeline, that the one that we know for all the traditional ML approaches, which is splitting our data. Our test size, we will keep it as 20% of our data for both of the data sets. We will be using the TF-IDF vectorizer, and something that I want to mention here is for these machine learning approaches, the way that we're vectorizing is that we're obtaining each of the words that we have across all of our tweets, and we're creating this type of vocabulary. But for us to obtain a little bit more context of where those words are in sentences and how they relate to each other, we're going to be using TF-IDF, which calculates the probability of certain words that are contained in certain document or in certain tweet. So it's a little bit better, and that's why we're using it. Then we will move forward to feed our model, and then bring our object to classify, train, predict the labels, and calculate the accuracy. So we're looking at accuracy for the tweets of 77%, which might be really good for an SVM classifier. It might be related for the data to be somehow linearly separable, but again, it will be very important to look at the actual predictions and see how it looks like. After doing some research within this, I would say that more of the subtle tweets are the ones that are normally failing, especially for these type of models. So SVM is really good with to capture like very frequent patterns. For example, really bad words that are very frequent. SVM is like really good at capturing those patterns and detect those tweets, but not tweets that are very subtle. So that's one disadvantage of this model. In the other hand, we have articles that has a 76% of accuracy, which might seem really good. And again, while looking at the results, we see that this is not true. It seems more of like a random result of accuracy rather than being a good model. And before jumping into deep learning, I will just look at some questions. For example, training sample is 80% and may lead to overfitting, which is right. Most of the times we want to look at the percentage that we're selecting. In this case, we selected 80% because we have a lot of tweets. So even 20%, we still have a huge test sample. But definitely something that we can tweak and we can look at. We can reduce it to 70 or 65%, depending on the approach that we're looking. And is it still possible to scrape data from Twitter for data science project? If yes, how can I go about it? I think it's no longer possible and you need to pay for the API. I haven't gone deeply into exploring the X API, given that you need to pay for it. There's a lot of data out there that was collected when the Twitter API was open. So before jumping into pay APIs, I would suggest to look at open data and maybe search for other type of projects. And besides Twitter, there are other type of social media platforms that provide APIs, for example, Reddit. Reddit has also an easy to follow API, and it's very easy to collect data from it. So I would suggest looking at some other sources too. Perfect. So I'll continue. Oh, and just another question. Also, what are alternative social medias? Yes, Reddit can be a good one. If there's another one I think about, I will definitely bring it back on the chat. Perfect. So we move forward to deep learning portion of it. And again, we're going to use a super baseline model in deep learning terms, a feed-forward neural network, which is one of the classic models that we have in deep learning. It's an artificial neural network where the information flows in a single direction. So we have all of our data going from an input layer and is passing and doing math operations through different layers to finally go into an output layer that will give you the result of the classification that we're looking for. Pretty straightforward. So when we think about binary classification, the input layer you can think about that is made up of neurons that is representing our data features. So remember, we were saying how we were vectorizing the words and we were bringing the probability of those words using methods such as TF-IDF. Those are represented through our neurons. And then we're just doing simple math, like sums and nonlinear functions throughout the different layers that we have. And finally, we have a sigmoid activation function, which will reduce all of our probabilities into a single range of either 0 or 1, which are the labels that we have. So we can think that we're just doing math between the layers, and at the end, we're just thinking of what is the probability that this text belongs to this class, and what is the likelihood of it belonging to the other class. The higher probability is the classification that we're going to give to that text. And the reason feed-forward neural networks and deep learning has become very popular, especially over machine learning models, it's because they can capture really complex patterns that are not so easy to do with machine learning methods. But in data science, as we know, there's no model that you need to follow every time. It really depends on the data that you're using and the projects that you're following. So definitely do not jump into a deep learning model. Try to explore some other models, see how they perform before jumping into these, especially because of the amount of resources that deep learning uses. Okay. Jumping into the code, we just described the architecture and I will not go very deeply into it. But it's just two classes where we're defining the architecture of our feed-forward neural network, and the forward pass where it's doing all the math for the architecture to learn our data and the patterns behind it. And we're doing something similar as we just did to machine learning. We are splitting our data. You can bring the same data that we already have. We're using TF-IDF again for vectorizing. We're passing those as tensors just so that PyTorch can input that into our architecture. And we're defining some hyperparameters. It's important to mention that again, we just use this model as a baseline just to compare it and just for this workshop. But hyperparameter tuning and hyperparameter exploring is something that you want to do when you are performing these type of models. You want to look at the number of layers that you have, the number of epochs that you want to compute, the optimizers that you want to use. There are many hyperparameters that you can tune and that can actually create really high changes in your model. So these are just the baseline hyperparameters that are normally used, but definitely it takes some time to go into them when you're using these type of solutions. Once we defined all of the hyperparameters that we want, we will be training our model. And again, the epoch is how many times it's training over the full data set. So it's learning toward a forward pass that is doing all the math, and in the backward pass is computing just some gradients that are calculating how good is the model actually learning compared to our data, and calculating the loss, which is how is my model not understanding my data fully. And at the end, we're just computing all of our metrics just to see how our model was doing. And this was a very brief explanation about deep learning. Just take into consideration, there are so many details into it that you need to look when you're developing these models. And as we mentioned, loss is a very important thing to look at. So for example, the accuracy of our feed-forward network is 76%. It's very similar to the SVM. But once we look at the results, we see that deep learning is actually able to capture more complex pattern than SVM. And the loss is also, we can see through the loss that is performing good, that this is a good performance of the model. It's going from 0.6 to 0.3 throughout our epochs. It has a small elbow that is the one that we're looking for. We don't want to overfit, so we don't want that many epochs. Actually, maybe less epochs would be better. We want to stay somewhere where our loss is smaller, but we don't want to overfit our model. So again, it's a baseline, but it gives us an idea of how these models might work, and if we want to spend more time fine-tuning and hyperparameter tuning these models to see if they will bring better results. On the other hand, for the articles, the accuracy says 71%, which if we only look at the accuracy, we might think, oh, that's great, we have a great model, that's it, we're done. But when you're actually looking at the loss or at the results itself, you can see that this is not a good model and that the accuracy might not be the best metric to evaluate that this is a good model. If we see the loss is changing very little from 0.7 to 0.5, even though the graphic might look like it's slowing, it's going very quickly. It's not right. If you look, for example, at this one, from 0.60 to 0.40 is going very quickly, but then it decreases, and that's the elbow that we're looking for. In this case, it's just decreasing. So there is a behavior that is not expected and that should be looked at. So these models shouldn't be used. So once again, don't focus on just one metric. Take a deep look at your model and at all the values that you're receiving, and especially at the results when looking at those models. And let me just look at the questions again. Once we have the model results, is it possible to see what examples are not well classified? Yes, for sure. So an important part of this is when we're predicting to keep the labels of the predictions that we have and then actually look at them. The reason I decided to not add that to the workshop is that, again, the text itself is very explicit. So I didn't want to bring those texts here, but I am open to share some of the results that in the past we have found for certain examples. And in terms of knowledge, yeah, I will share that subtle misogyny or text that has subtle misogyny is the one that is harder for the models to understand. So definitely it's a very important step to look at the results of your model by like a human looking at them as well. Is there another parameter to evaluate the SVM model for the processing of words that you scrape? There are different metrics that are important to look at, not only accuracy, there's precision, there's F1 score, there's ROC. There are many metrics that are important to look at. I would suggest to look at the metrics, but again, also look at the results of the SVM as well. And for SVM specifically, again, SVM is a linear classifier unless you add a kernel to it. So also visually, if our data points are linearly classifiable, then it makes sense to use SVM. So I would suggest also to, if your data set allows, that you perform a visual representation of your data points to see if there's a linear separation, just to see if your model is doing correctly. What is training loss? I think that might be, it's more of the math part of the feed-forward neural network, but very general. We can say that when our model is learning throughout the layers, it is learning certain patterns. And after doing a forward step, which is just doing certain math in the network, it's calculating a backward step, which is comparing the results to this text to see if what the model learned was actually right. So the loss, it's just comparing to see what we train on is actually the patterns that we're looking for. And loss is just a number that will calculate, oh, actually we're losing all this knowledge within our feed-forward network. So when we're training a feed-forward network, we're training it for it to reduce the loss as much as possible. That's something that we're looking for. So it's an important metric to look at, but this is just a very very general explanation of it. And all the models using the notebook are open to access. Yes, right now the SVM, we use it through the sklearn library. It contains many types of models. There's a lot of documentation about sklearn, so I suggest looking at it. The feed-forward network is using through PyTorch. PyTorch has also a huge amount of documentation. There are some other libraries to perform deep learning, which they are also open. It really depends on user preference on which ones do you want to use. And we will jump into another library that is also open. So all of the data that we're using here, it's open, and all of the libraries are open as well. Perfect. So we can move forward into the large language models, which is something very popular right now. I think everyone nowadays has heard of ChatGPT, has even used it. Most people have used it, or at least you know someone who uses ChatGPT. So it became really popular because of its public release, but we can actually see that large language models have existed for a very, very long time. So some authors don't consider some of these models large language models, maybe some of the recent ones, but their research around text and how can we use these deep learning architectures around text has existed for a very long time. And what is this large language model? Well, an LLM is just a statistical model, which are typically based on deep learning architectures like the one that we just saw. But their special feature is that they're trained on a massive amount of data. And when we say massive, it's a very, very big amount of data. When we started with transformers and BERT around 2017, 2018, we were talking about millions of parameters. And then throughout the years, we jumped to billions a couple of years ago. And some of the recent models that came out last year and this year are now jumping into trillions. So when we think about trillions of data, we're talking about these massive models. They are very heavy, they are very computationally expensive. But because of that huge amount of data, they're able to have, they are very good for different types of tasks. For example, they are very good at text generation, which is ChatGPT. ChatGPT is text generation. We also have translation or text classification, which is what we're trying to do today, classify text. So these very, very huge models are also very popular because they are scalable to certain tasks. For example, you have ChatGPT, which might be good answering some of your questions, and might seem to answer like a human sometimes. But sometimes we want ChatGPT to have certain knowledge or certain things, and it's not good. So we can actually fine-tune those models to improve their performance on the tasks that we want, which is what we want to do today. We have these large language models and we have the knowledge about misogyny. So we want to tell the model, hey, take this knowledge about misogyny and learn it so that you can be able to perform these given all the context of data that you were trained previously on. So this is called fine-tuning. And again, it's just the process of adjusting the model's weights by using a smaller data set. And when we say smaller, it can be anything smaller than trillions, as we just mentioned, to better fit any kind of task that you're looking for. So for example, imagine that one of our models is this little bird here, and the bird was trained in trillions of tokens that came from the library. So this bird knows a lot. But this bird happened to not know about these 3 specific books. And we want the bird to become an expert on these 3 books. So we give it to them, we fine-tune the model for it to learn about these specific books. And now the bird, it's an expert. So that's what we're looking forward to do. And for this, we're going to be using the Hugging Face library to access these models. Again, these models are very huge and very expensive. So we're not able to train on those trillions of data sets. We're able to obtain the model through their API and just add our text on top of it. And even that, it's a little bit expensive. And some of the code that we've been going through. It has been developed throughout the last years by me and some other developers that are acknowledged at the end of the notebook. But for this specific part, I use some code that was open online and some code that was developed by me years ago. So just wanted to share the link to those notebooks that were used. And before jumping, let's read some of the questions. Yes, especially the LLM models. I think this question is related to the packages. And yes, Hugging Face has an open API. It's an open API that you can use and download models. Not all the models, not all the LLM models are open to the public. For example, Google just brought their Gemini model and they created an open version of it, which is Gemma, which is open. But for example, there are other models like GPT-4. GPT-2 is open, but GPT-4 is not open. So we cannot access to it. But Hugging Face shows the ones that are public and are open, so we can use it. And there's another question about the linear separation of our data. And again, this is a little bit more on the math side of it. So imagine you have your data points, and if you can think about a visualization of your data points on a square or in a space, imagine you have your two classes, and we are every dot is a tweet. So imagine you have all of our tweets, and just because of the way that the text is created, all the tweets in one class are right here, and all the text in the other class are right here. So there's a linear separation between them. I can talk a little bit more about at the end, and we can bring some images, which I think will help more to solve these questions. I will leave some time at the very end just to go through them. Can we go for prompt engineering instead of fine tuning? Yes, prompt engineering, it's very similar to fine tuning. It's the way that it is injected into the model, and sometimes prompt engineering can be it really depends on the solution that you're looking for. It's something that you can do, especially since it involves a human inputting the prompts, but the process of doing so is different, and the results might change a little bit, but it's something that you can do as well. Any advice on how to get started with NLP and LLM for a beginner? I would definitely say to get more and more familiar with NLP and all the baseline methods before jumping into these LLMs. I'll be going through the code just in a very general manner, just to explain how it is not that hard, but there is a lot of things and new things around LLMs that are important to understand. And do we need to learn the foundation for NLP before we can learn LLMs? Yes, definitely. A little bit of NLP experience might make it easier for you. And can you recommend some online courses? Yes, I'll share them in the chat at the end of the workshop. And thank you for your questions. We will start with the models. We're gonna be looking at 3 models: BERT, Roberta, and GPT-2. BERT is from 2018. Roberta is the same architecture as BERT, but it was trained with more data in Spanish and with tweets, so it might be better for the task that we want to do. And GPT-2 is also from 2019, but it's a complete different architecture from BERT and Roberta. And you might be thinking, well, if we have these amazing models that are more recent, why don't we use them? I will always suggest to start with the smaller models, just because of how expensive it is to run the bigger and bigger models. So I would suggest to start small, start with some smaller models, maybe try something out, and then see if you can scale to the bigger and more recent models. So again, we're just calling the Hugging Face library. Google Colab might require you to install transformers. Maybe you don't need to. And for this LLMs part, I would suggest for you to not run the code immediately, just because it takes a long time to run. So maybe you just want to look at the results before start running, because it might take a while. And we're just calling our libraries and we're just setting up our hardware. Either you have a CPU or you have a different type of memory access, such as GPU, TPU, or whatever you have. And the first part, again, remember the first part of our pipeline in whichever project is always to generate tokens and embeddings. So to pass your text to something that your model can use. And in this case, it looks similar to what we know, but something that I wanted to share is the OpenAI tokenizer. It's an interactive way of knowing how this works for LLMs. So they are doing something very similar to what we did, but instead of splitting by words, they split to certain frequencies based on their own models and techniques. And each model has their own vectorizer and they all work differently. So you might need to look at the vectorizer method and understand what are they doing, but this is just an idea of how they work. So when we say vectorizing, just think of we're splitting our huge sentence into smaller pieces for the model to bring it up. Okay, so that's what we're doing here. We're just calling the tokenizer of each of our models, and we're just giving different parameters to each of them. And an example of that would be this piece of code. For example, our original tweet says, van bien, they're going good, huh? So that is tokenized by this tensor. So when we're saying tokenized, we're just transforming our text into something that can be readable by our model. Furthermore, we're bringing those tokens into embeddings, which is, again, part of the first part of our pipeline, where we're splitting our data set into training and validation, and we're bringing some other important parts, which are the data loaders and our batch sizes. So large language models split the data by batches, so they will learn a batch of text, calculate how are they doing, a batch of text, calculate how are they doing. And LLMs normally mention that you should use a small batch of text. So they won't input all of your text, all of it into the model. They will be looking at smaller pieces of your text. So normally they recommend your batch size to be 32 or 16, depending on the architecture. We have some helper functions for fine tuning, and now we're jumping into the code for fine tuning. So again, fine tuning, we're gonna see this model somehow similar to training the deep learning model that we had before. So we're calling an optimizer, and here we're just setting all the variables related to what we're gonna start running. So in a similar manner, we have epochs, where again, each epoch, it's a full pass over the training set, but we're going through the batches. So we're gonna learn each of the batches, we're gonna perform the math, and after going through all of our batches, and after we went through all of one full pass of the training set, that's one epoch. So the model will be continuously learning about all the text that we're inputting. There are another methods related to these really long architectures, which is attention, labels, how position encoding, clipping the norm. So there are many technical parts of the LLMs that are important to discuss. So take that into consideration when you're building and fine-tuning these models. There's a lot to understand about a model when you're trying to look at it. And at the end, we're also calculating our loss and our validation at the end. And we want to use our validation set that we left aside for a second so we can actually see how our model is performing. And we're storing all of that information into a single data frame so we can look at our stats at the end. So those were just the functions so that we can actually fine tune. So let's bring those back. And again, we're doing our pipeline, tokenizing, putting those tokens into an embedding, which is grabbing up into our text so it can pass into our model. Here we're calling the model that comes from Hugging Face. We're just passing some hyperparameters right there. And now we're using our fine-tune function to actually fine-tune the model that we just called right here. And after doing so, we can see that it's training, and we start with a validation of 78%. Again, we're fine-tuning tweets against BERT, but it jumps pretty quickly into something close to 82%, which is great. And we will be looking at the stats at the end. Furthermore, we did the same for Roberta, the same process. Roberta uses the same tokenizer as BERT because they are the same architecture, so we're loading the same one, doing the same for the embedding, calling our model, and just fine-tuning, performing the exact same. And we'll look at the results in a minute. Finally, we're doing GPT-2. GPT-2 requires a little bit of setup for the embeddings, but it's pretty similar. We're calling our tokenizer, setting up certain things, embedding our text, calling our model, and then finally fine-tuning our model and looking at our results. So perfect, we fine-tuned 3 models. We can see that BERT provides the best accuracy overall, which is around 82%, and we can see that it's around epoch 4, it's staying still. So we would recommend to maybe stop at epoch 3. And both BERT and GPT-2 have kind of the same behavior, which is the type of behavior we're looking for, but GPT has a lower accuracy. Compared to Roberta, that doesn't have a very clear behavior. It seems like at some point it stayed still, but maybe it learned something. And this really depends on the type of data that maybe saw at the end. Also, again, Roberta is the same architecture as BERT, but Roberta was fine-tuned or was trained on more data in Spanish, and especially in tweets. So maybe for the model, there's a little bit of confusion for having too much tweets that is not able to detect misogyny. So again, when we're looking at fine-tuning these type of large language models, there's a lot of things to look at. We need to look at the tokenizers, we need to look at their architectures, their methods, which data they were trained on, if they were fine-tuned, for how long they were trained on, the parameters they are using, the optimizers they are using. BERT has, in the past, has shown that it's very good, even though BERT is from 2018, it's still very good at sentiment classification because of its tokenizer. So it's very important to, again, not jump into the newest and recent models, but rather look at the solution that you have and research a little bit of what has been developed around that solution. And finally, since BERT was the best model that we could obtain, we will only fine-tune the articles for that specific model. For the articles, we do have a very, very small data set. And unfortunately, that is showing on the accuracy. This behavior on the accuracy just staying still means that the model is not performing okay. There might be something going on. We will need to take a deeper look into the model, but something that we can look at, it's at the loss. And you can see that the loss is slightly decreasing, which is what we're looking for, but very slightly. So again, this might be related to the small amount of data that we have. So super quickly going into the results so we can jump into the questions. LLMs outperform the traditional machine and deep learning methods, especially for subtle misogyny. When looking at the results of these models, we were able to look at that LLMs are capable of detecting when an article is sexist compared to an article that is not, even if they are describing a very, very similar fact. So LLMs have a very good performance with really, really small patterns. So it might be something that we want to keep exploring. And BERT did give back the best results, and this might be related to its feature of being really good for sentiment classification. And to wrap up, during this workshop, there's a lot going on. We clean data, we train supervised models, from machine learning to deep learning to large language models. There's a lot of knowledge that has to go around these. But we were able to see that there are ways to collect patterns that we can actually use to detect misogyny. So we can use technology for these type of problems, but there is a lot of analysis that is needed to perform these before putting them into practice. So as a future work, I would suggest just to find more ethical ways to label and clean data sets, gather information maybe in other languages. I would suggest to everyone looking just to look at other languages besides English and provide more open source data sets and just comparing these type of problems and explore and fine tune different models with different hyperparameters. Again, use these models as a baseline, but don't take these as the best model or as a golden standard. There's a lot of work before bringing a solution out. And just an acknowledgement for all the people that have been working on this research. And thank you so much for being here and for staying till the end. I think I'll jump straight into the Q&A in case someone else has more questions for the last few minutes that we have. One question is, how do you deal with irony and sarcasm? That's a very important question. I was the one who was manually labeling the data sets, so also that's a very important thing. It was just one person labeling, which might lead to not a high quality data set, and also subjective to what I think it's misogynistic or not. So when I was labeling the tweets, there's irony that can be misogynistic, and there is sarcasm that can be misogynistic. And at the end, that's very subjective, because someone can be saying something that might be sarcastic and they are not trying to be misogynistic, but the other person might take it as not sarcastic and misogynistic. So some of the developers that are working around these problems suggest that if there is a small hint of a sentiment within your text, the best that you can do is to mark it as it having a sentiment. So you would rather have a model that overreacts to misogyny rather than a model that never catches misogyny. And a way to deal with this that has been developed over the last years is to use percentages. So instead of having a model that says it's either misogyny or is it not, having a model that says there's a 20% of chance that this is misogynistic. But yeah, those are the very important details to look at when you're looking at these solutions, like the social part of it, the human behavior behind these texts. Like overall, the technical part it's intense and it's important to look at, but also the social part of it and understanding our human behaviors so that we're bringing the most ethical solution every time. Yes, I'll share, and the question says my LinkedIn handle and the access to the file. So I think I can share both. I'll share, I think you all have access to, well, I think Amy can share the link to the folder that contains the notebook. My LinkedIn is Valeria VLA. Thank you so much. And my next big project, thank you so much for asking. That's a really nice question. I am looking forward to continue this research. I started it as an undergrad around 4 years ago, and I've been working on it. I have really enjoyed working on it, and I wish I can continue. I really enjoy doing a lot of tasks related to human behavior and text, and I think it's really important to continue to work around these. So I would be happy to jump into other type of problems that are related to all these kind of tasks. Thank you so much. I think yes, and there are resources to learn and get started. Yes, I would suggest, I started using the LinkedIn classes that they have, LinkedIn Learning. They have some really good resources. If you feel like you have enough experience by reading, then I would suggest to start doing Kaggle competitions. Kaggle competitions are a way to obtain really good access to data sources and hardware resources. And I would suggest to get your hands into the code as soon as you can and explore a lot. And if anyone has any questions, please reach out to me. I would be very happy to talk about this.
Thank you very, very much, Valeria, for this amazing workshop. Maybe a couple of questions. We still have a few minutes. Maybe the first question is, can you please suggest, or at least let us know, why are you using NLTK instead of something like, for example, spacing? There are some advantages or some recommendations, like a specific things that we should learn, or that someone that want to start with in the world of NLP can learn to, do this kind of research or this kind of projects.
Yes. So looking at the tools and the libraries that you use is something very important. That was something that took me a while. I started exploring different type of libraries, especially because, again, there are so many resources for English, but not so other for other languages. So when I started to use, for example, another type of NLP technique, which is called lemmatization, which is truncating the words at the end, um, it was performing really bad in Spanish. It was changing words into some others that didn't make sense, especially Spanish from Latin America. That's when I realized that these libraries are not so good. I actually have a research where I looked at the Spacey library, and while doing these, the accuracy with English text is something close to 99%, and with Spanish from Latin America is something close to 70%. So there's a huge jump in these libraries, and I would definitely suggest to look at them. The reason I use NLTK, at the point of when I did this research, I think there were not so many stop words lists, and I think NLTK is one of the most popular ones. But yeah, definitely every time I use it, I take a look at the words, I see how it has changed, and I modify it for the projects that I have.
Okay, thank you. Thank you very much. And yes, and there is a huge difference between English and Spanish. And I guess with this project, you were able to just really see those differences between working with, a text in English and text data sets in Spanish. What were the nuances that you found specifically for this project?
Oof, I think there are so many things to look at. Since the definition of misogyny, how it looks like in Spanish, how it looks like in English. When I started this research, I only found another research that was doing misogyny detection, and it was doing it in Italian. And the type of text they were looking at, it was a huge cultural shock to see how different countries define misogyny. Even Latin American countries, I think throughout language, you can see the social context of those countries and seeing how it's very different based on what they're going through. I think that was a huge shock. And that's why I would encourage people to always explore like within their community and within their local resources. That's what we know the most about. I was born and raised in Mexico, lived there most of my life. So my context is around that. And use the knowledge that you have around your community as much as possible.
Okay, yes, definitely. Thank you very much for that. And there is a question in the chat. We had a question in the chat, and someone were asking about what is an API?
Oh, that's a great question. Yeah, we just mentioned it so much. So an API is just an interface. An easier way to explain it, it's just an interface. So you have a piece of software that someone developed somewhere. So a certain company decided to, for example, create these models. And an API, we can see it as a bridge for us to reach that code in an easier way. So an API is just like a wrapper around certain piece of code that you want to use for you to use it in the most efficient and easier way.
Yes, thank you very much. And I'm glad that you got all the tweets before all the changes to the API. Okay, so thank you very much, Valeria. That was an amazing workshop. Thank you for sharing all your knowledge around this subject today. We're very glad. Thank you. Thank you very much.
Thank you. Thank you everyone for attending.